Imagine a world where materials don't just react to their environment, they adapt to it. What if certain crystals could breathe like us, inhaling and exhaling oxygen as needed to power everything from clean energy devices to smarter electronics? Well, this isn't a science fiction concept anymore. Researchers have just made it real, and it's about to change everything. Fuel cells have long been heralded as the future of clean energy. These devices convert chemical energy into electricity with minimal emissions, making them ideal for everything from electric vehicles to stationary power plants. However, there's a major issue. These fuel cells require extremely high temperatures, often between 600 to 1,000 degrees Celsius, to operate effectively. At these elevated temperatures, the materials inside the fuel cells begin to degrade over time. This not only reduces the system's efficiency, but it also results in higher maintenance costs. For years, engineers have been trying to find ways to make fuel cells more durable, cost-effective, and capable of operating at lower, safer temperatures. This challenge seemed insurmountable until now. A team of researchers from Pusan National University in South Korea and Hokkaido University in Japan has discovered a groundbreaking solution. They've developed a new crystalline material made from strontium, iron, and cobalt, a combination of elements that hasn't been used in this way before. What makes this material so extraordinary is its ability to breathe. When heated to a relatively low temperature of about 400 degrees Celsius, 752 degrees Celsius, it can release oxygen, and when cooled, it can absorb oxygen back into its structure. Essentially, the crystal inhales and exhales oxygen, much like how we breathe, without breaking apart, even after many cycles. This development is a major breakthrough. Traditional materials used in fuel cells, like zirconia or yttria-stabilized zirconia, have to withstand extreme temperatures, sometimes up to 1,000 degrees Celsius. But these materials are fragile and begin to degrade over time, which reduces their efficiency. The new Strontium-Iron-Cobalt crystal, however, operates at much lower temperatures, making it much more efficient, durable, and cost-effective. It can handle repeated cycles of oxygen absorption and release without degrading, which means fuel cells can now be used longer and more effectively. By operating at lower temperatures, this new material could dramatically reduce the energy required to run fuel cells, resulting in cheaper and more efficient power generation. Whether it's powering an electric vehicle or a stationary power plant, the implications are vast. But the material's potential isn't limited to fuel cells. In fact, it could revolutionize other industries that rely on managing heat and energy. One fascinating application is in thermal transistors, devices that manage heat flow in electronics. Overheating is a common problem in smartphones, laptops, and other electronics, leading to performance slowdowns or even permanent damage. By using this new crystal, thermal transistors could regulate heat with much greater precision and efficiency. Imagine a smartphone that never overheats, no matter how many apps you run. The breakthrough crystal could make that possible. Another promising application is in smart windows. These windows could adjust their transparency based on environmental conditions, such as sunlight or outdoor temperature. With the help of this oxygen-breathing crystal, smart windows could absorb or release oxygen, altering their opacity and helping buildings maintain optimal indoor temperatures without the need for extra heating or cooling systems. This would result in significant energy savings and make buildings more sustainable. The core of this innovation lies in the crystal's ability to undergo a process known as oxygen reduction and oxygen incorporation. When the strontium-iron-cobalt crystal is heated, oxygen atoms from the surrounding environment are absorbed into the crystal lattice. The oxygen ions become trapped within the material's structure. When the material is cooled, these oxygen ions are released back into the environment. This reversible reaction, essentially the crystal breathing in and breathing out oxygen, is what allows the material to function so effectively in fuel cells and other applications. This property, known as oxygen ion conductivity, enables the crystal to control the flow of oxygen within fuel cells. This is critical because oxygen is the key to generating power in a fuel cell. By absorbing and releasing oxygen at will, the crystal can maintain a constant, efficient flow of oxygen without degrading over time. This is what makes the material so special. It's durable, efficient, and can withstand the harsh conditions inside a fuel cell, ensuring long-term performance. The potential impact of this discovery is immense. Beyond clean energy, it could lead to smarter, more energy-efficient electronics, eco-friendly building materials, and self-adjusting systems that react to their environment in real time. Imagine a world where cities are powered by clean, renewable energy, where our homes and offices maintain the perfect temperature without energy wastage, and where our devices remain cool and efficient no matter how much we use them. This breakthrough could be the key to a truly sustainable future. This research isn't just about creating a better fuel cell. It's about rethinking how we design, build, and interact with the technologies that shape our world. From power generation to smart buildings to everyday gadgets, oxygen-breathing crystals could play a pivotal role in making our world more energy efficient and sustainable. It's an exciting glimpse into the future, one where science and technology work together to solve some of our biggest challenges. So, could these crystals be the next big thing in clean energy? The possibilities are certainly endless. Whether it's transforming the way we power our vehicles, buildings, or devices, this innovation marks a pivotal step toward a cleaner, smarter, and more sustainable world.